Hi everyone, the next topic is hot values. So this statistic gives the information on influential points. So in linear regression, that we check if observations are influential or not. If a few observations gives too much influence on the regression result, that result isn't robust because if we change the data a little bit, then regression model can change a lot. And recall that in linear regression, y is equal to x beta plus epsilon, the hot value hjj of the hot matrix H, this matrix, is how influential the J's observations is. So a large value of hjj means observation is more influential for the regression result. So we have studied Cook's distance. So in linear regression, basically Cook's distance is hjj over 1 minus hjj. Hjj gives a larger Cook's distance. That means that we have larger influence on. So basic idea is that if we have x and y, suppose for simplicity, we only have one predictor x, we have observations here and we have observation here, then these observations end or left end have larger influence on regression line. So the logistic regression, we can define quantity, but with some adjustment. So adjustment is just needed because logistic regression uses inverse logit function as a link function. So that affects a little bit, but we can h sub jj to check. So in short, this hjj, right? So the hot value of logistic regression, if we calculate, we can get hot values each observation. So these 2001, 2002, so these are ID number for volunteers. So here, at least we can see that this number is largest, 0.001. This is 0003, 0005. So this is at least more influence on the regression model than other observations. So to see distribution of these hot values of logistic regression, we can make the QQ plot. And this is the normal QQ plot here. So you can see that there are few observations. So these observations have large influence. In the previous page, we could see that typically the influence is 0.0005. So this one has the hot value of 0.02. So 0.02. So this is 40 times larger. So it might be too influential to the regression result. Yeah, so here a normal QQ plot is used to just see outliers, these outliers. And observations are not expected to be distributed normal. So normal QQ plot is similar to histogram. So histogram, even if we know that it's not distributed normal, we can make histogram to see the shape of the graph. And the QQ plot is the same thing. But for QQ plot, it's easier to see these extreme values. So that's why we used QQ plot instead of histogram. So this is the explanation for the hot values.